Hi, my name is Eyuche Okorie and I am a NexGeneGirls Summer Science Intern. This summer I was in the Srivastava lab at the Gladstone Institute and I was studying the interaction between two cardiac transcription factors, which are islet-1 and NKX2.5. So the reason I'm interested in studying these two proteins is because when they're absent, the heart actually doesn't develop properly. So you can see here, when islet-1 is missing, the outflow tract and right ventricle aren't even forming. And then in NKX2.5, when that's knocked out, it doesn't actually have the outflow tract either. So I wanted to understand more of their role in cardiac development, which is why I asked myself 3 questions. First being, does islet-1 bind to the islet-1 motif? 2, does NKX2.5 interact with islet-1 when islet-1 is bound to its motif? And 3, do islet-1 domain mutants and variants disrupt islet-1 binding? So I answered these questions by performing EMSAs. And an EMSA is an electrophoretic mobility shift assay, which is essentially a gel that will show me that my protein of interest is binding to DNA at the motif that I've chosen. And I was able to choose this motif by looking at ChIP-seq data, which shows me peaks where my protein of interest is likely to bind. So we engineered these probes for islet-1 and NKX2.5, and then I performed nuclear extractions on NKX2.5 and islet-1 to get the protein from the cell. And then I performed an AP1 control EMSA to see that my EMSA was actually working and I was doing the experiment right. And then I moved on with doing optimization assays where I saw that upon addition of magnesium chloride and NP40 to my binding reactions, islet-1 is binding to its motif. And then I did an islet-1 antibody supershift assay to see if islet-1 was actually the protein that I was seeing on the gel. And because I saw this shift, I knew that I did do it right and islet-1 is actually that protein. So the next thing I did was use NKX2.5 and islet-1, and what I saw is that islet-1 was still binding to its motif, but NKX2.5 was not interacting with islet-1 when islet-1 is bound to its motif. And then I tested domain mutants, so homeodomain, limb binding domain, limb-1 and limb-2. And what I found is that the homeodomain is essential for islet-1 binding, but limb-1, limb-2, and limb binding domain aren't actually necessary. So in the future, I plan on testing different domain mutants for islet-1 and NKX, and I want to test a DNA probe that has an islet-1 and NKX2.5 motif combined and see if that actually disrupts interaction or binding with islet-1 or NKX. And I want to clone different NKX2.5 variants to again see if binding is disrupted. I would like to acknowledge Bonnie Cole, my mentor over the summer, and Deepak Srivastava, who was my PI. But lastly, I'd like to give a special thanks to the NexGeneGirls summer program for giving me this research opportunity.